Next problem, find the Fourier sine transform of f of x is equal to cos kx. So given f of x is equal to cos kx, that is equation number 1. We know finite Fourier sine transform defined in the interval 0 to pi given by fs bar of p is equal to 0 to pi integral 0 to pi f of x sine px dx. This is equation number 2. Using 2 in 1 in 2, so fs bar of p is equal to integral 0 to pi cos kx sin px dx. That is equation number 3. We know that the formula cos a cos sin b, which is equal to 1 by 2 sin a plus b minus sin a minus b. So here a is equal to kx, b is equal to px. So 3 implies fs bar of p is equal to 1 by 2 integral 0 to pi sin a plus b kx plus px minus sin a minus b kx minus px into dx, which is equal to 1 by 2 integral 0 to pi sin k plus px minus sin k minus p x dx. So separating into two integrals, so 1 by 2 integral 0 to pi sin k plus px dx minus 1 by 2 integral 0 to pi sin k minus px dx. That is equal to 1 by 2 minus cos k plus px by k plus p, lower limit 0, upper limit pi. Then minus 1 by 2 minus cos k minus px by k minus p, lower limit 0, upper limit pi. Because we know integral sin ax plus b, which is equal to, or sin ax, integral sin ax dx is equal to minus cos ax by a. So in the first integral, instead of a you are having k plus p. In the second integral you are having k minus p, right? So applying the upper and lower limit, 1 by 2 minus cos k plus p pi by k plus p plus cos 0 by k plus p plus cos k minus p pi by k minus p minus cos 0 by k minus p, which is equal to 1 by 2 minus cos k plus p pi by k plus p cos 0 1 plus 1 by k plus p plus cos k minus p pi by k minus p minus 1 by k minus p. So half into, so taking LCM k plus p into k minus p. So k plus p into cos k minus p pi minus k minus p into cos k plus p pi plus k plus p minus k plus p, right? Plus k minus p minus k plus p, that is equal to 1 by 2 k, separating, so removing each bracket, multiplying k with k cos k minus p into pi, right? Then plus p into cos k minus p pi. Then second term minus k into cos k plus p pi minus into minus plus p cos k plus p pi. Then k minus p minus k minus p. So k minus k get cancelled. So 1 by 2. So k into cos k minus p pi plus p cos k minus p pi minus k cos k plus p pi, then p cos k plus p pi. So p minus p minus p minus 2p. Then this is equal to k into cos we are using cos a minus b formula, right? So a is a minus b, right? Cos a cos b plus sin a sin b. Here a is multiply with pi, right? K pi is a and p pi is b. Using that formula, cos k pi cos p pi plus sin k pi sin p pi is first one. Similarly for the second one, p into cos k pi cos p pi plus sin k pi sin p pi. Then cos a plus b is equal to cos a cos b minus sin a sin b. So similarly here, first a is equal to k pi and b is equal to p pi. So minus k into cos k pi cos p pi minus sin k pi sin p pi plus p into cos a minus b formula. Cos k pi cos p pi minus sin k pi sin p pi minus 2p by k plus p into k minus b, that is k square minus p square, right? That is equal to half into k cos k pi cos p pi plus k sin k pi sin p pi plus p into cos k pi cos p pi plus p into sin k pi sin p pi minus k into cos k pi cos p pi plus k into sin k pi sin p pi plus p into cos k pi cos p pi plus p into sine k pi sine p pi minus 2p by k square minus p square. So 1 by 2 k cos k pi cos p pi plus p into cos k pi cos p pi, then minus k into cos k pi cos p pi plus cos k pi cos p pi minus 2p. Because we know sin p pi is always 0, right? So we removed all those terms which are having sin p pi, right, divided by k square minus p square. So that is equal to 1 by 2 times p cos k pi cos p pi, because see k cos k pi cos p pi minus k cos k pi cos p pi get cancelled. So remaining term 1 by 2 into 2 p cos k pi cos p pi minus 2p by k square minus p square. 2 is common, take it outside. Numerator 2, denominator 2 get cancelled, right? Cos k pi minus cos p pi minus 1 by k square minus p square. So p is also common, take it outside. So you will get p by k square minus p square into cos k pi into cos p pi minus 1. So taking minus outside, you will get minus p by k square minus p square 1 minus cos k pi cos p pi. So cos p pi can be written as minus 1 power p, right? Similarly cos k pi also minus 1 power k, right? That is right. It is okay. Therefore fs bar of p is equal to p by p square minus k square 1 minus cos k pi into minus 1 power p. So another method from the above 3 implies fs bar of p is equal to 1 by 2 minus cos k plus p pi by k plus p plus 1 by k plus p plus cos k minus p pi by k minus p minus 1 by k minus p, which is equal to 1 by 2 minus cos k plus p pi by k plus p plus cos k minus p pi by k minus p plus taking the LCM of the remaining term k plus p into k minus p. So k minus p minus k minus p, which is equal to 1 by 2 minus cos k plus p by k plus p plus cos k minus p by k minus p plus, so k minus k get cancelled, minus 2p by k square minus p square, right? Okay, then that is equal to 1 by 2 minus, so cos k plus p pi, we are using the formula because cos n pi which is equal to minus 1 power n. So instead of n you are having k plus p, so that is equal to minus 1 power k plus p by k plus p, right, plus minus 1 power k minus p by k minus p plus minus 2p by k square minus p square, right? That is equal to 1 by 2 minus taking LCM k minus p into minus 1 power k plus p plus k plus p into minus 1 power k minus p by k plus p into k minus p. So we are reversing the denominator. Instead of k square minus p square, we are writing p square minus k square. So you will get one more minus, that minus and minus get cancelled. So you will get plus 2p by p square minus k square, which is equal to 1 by 2 minus k minus p minus 1 power k minus 1 power p, splitting the power of minus 1 plus k plus p into minus 1 power k minus 1 power p plus 2p by p square minus k square. So 1 by 2 minus 1 power k minus 1 power p divided by k square minus p square, take it outside from the first term. So remaining you are having minus k minus p plus k plus p minus 1 power minus 2p, right? Because we are taking minus 1 power p in the second term, right, in the previous step, right, the numerator k plus p into 1 minus 1 power k minus 1 power minus p. So if you are taking plus p, you have to add one more minus p, that is why you are getting minus 1 power minus 2p, which is equal to 1 by 2 minus 1 power k minus 1 power p k square minus p square minus k plus p plus k plus p, because minus 1 square minus 1 power minus 2p can be written as minus 1 square whole power minus p. Minus 1 square is plus 1 power minus p, you will get 1 only. So that is why we removed that term. So minus k plus p plus k plus p, that is a plus 2p by p square minus k square. So minus k plus k get cancelled. So 1 by 2 minus 1 power k minus 1 power p by k square minus p square into 2p plus 2p by p square minus k square. So 1 by 2 2p by p square minus k square we are taking. So that is why you are getting minus in the first term, right? Minus 1 power k minus 1 power p plus 1. So 2 and 2 get cancelled. So you will get fs bar of p is equal to p divided by p square minus k square 1 minus minus 1 power k minus 1 power p. So instead of minus 1 power k, you can write cos pi k pi, right? Thanks.